What if space hides something so extreme it defies imagination completely? Beyond planets and stars exists a force more powerful than anything known. This extreme phenomenon bends reality itself and challenges our understanding. Scientists have studied it for decades, yet still remain deeply puzzled. It is not just dangerous, but completely unstoppable under known physics. This is the most extreme thing humanity has ever discovered in space. It begins with a massive star reaching the end of its life. When fuel runs out, gravity suddenly takes control without resistance. The star collapses inward at unimaginable speeds, crushing everything inside. In seconds, its core becomes infinitely dense, creating something extraordinary. What forms next is known as a black hole. Terrifying and powerful, its gravity becomes so strong, nothing can escape its deadly pull. Not even light can break free. Once crossing its invisible boundary, that boundary is called the event horizon, point of no return. Crossing it means disappearing forever from the visible universe outside. But what makes black holes truly extreme goes far beyond this. At their center lies something scientists call a singularity of infinite density. Physics, as we know it, completely breaks down at that mysterious point. Time and space behave in ways we cannot fully understand yet. Imagine falling into a place where time itself begins slowing dramatically. To an outside observer, you would appear frozen at the edge forever, but for you, time continues moving until reaching the unknown center. The journey inward would stretch your body in a process called spaghettification. Gravity pulls stronger on your feet than your head, tearing you apart. This is not science fiction, but real predictions from modern physics. Some black holes are millions of times more massive than our Sun. These giants sit silently at the centers of galaxies, controlling everything nearby. Even our own galaxy has a supermassive black hole at its core. It influences stars, gas, and dust with its overwhelming gravitational force. Yet despite their power, black holes cannot be directly seen by telescopes. Scientists detect them by observing how nearby objects behave strangely. Stars orbit rapidly, and light bends unusually near these invisible monsters. In 2019, humanity captured the first image of a black hole shadow. That image confirmed decades of theories and shocked the scientific community. But black holes are not just destroyers, they also create cosmic chaos. When matter falls in, it heats up, releasing enormous amounts of energy. This process forms bright disks, spinning rapidly around the dark center. Sometimes powerful jets shoot out from black holes at near light speed. These jets can stretch across galaxies, impacting regions far beyond their origin. Such extreme behavior shows black holes are anything but simple objects. They are laboratories where the laws of physics are pushed to limits. Scientists believe studying them may unlock secrets of the entire universe. Some theories even suggest black holes could connect to other dimensions. Others propose they might lead to distant parts of the cosmos. These ideas remain unproven, but continue exciting scientists around the world. One question remains deeply mysterious: what happens to information inside? Does it disappear forever or somehow survive within the black hole? This puzzle is known as the black hole information paradox. Solving it could revolutionize physics and change our understanding of reality. Surprisingly, black holes are not completely eternal, as once believed. They slowly lose energy through a process called Hawking radiation. Over billions of years, they can shrink and eventually vanish completely. This discovery changed how scientists view the life cycle of black holes. It shows even the most extreme objects are not truly permanent. Yet their existence continues shaping galaxies and influencing cosmic evolution. Without them, the universe might look very different than it does today. Black holes remind us how little we truly understand about space. They challenge our knowledge and push us to explore deeper mysteries. Every new discovery brings more questions rather than simple answers, and that is what makes them so fascinating and terrifying simultaneously. They are the ultimate example of nature's extreme power and mystery combined. But black holes might not be the only extreme things in space. Even more shocking phenomena could exist, waiting to be discovered someday. The universe is vast and full of secrets beyond imagination. And this is only the beginning of our journey into extreme space. Just when you think black holes are the ultimate extreme, something else appears. Imagine an object so dense a single teaspoon outweighs entire mountains. This is not fiction, but a real cosmic object called a neutron star. Formed from collapsed stars, these remnants push matter beyond normal limits. Their gravity crushes atoms, forcing protons and electrons into neutrons. What remains is an ultra-dense sphere, barely 20 kilometers wide, yet it contains more mass than our sun packed tightly together. Standing near one would mean instant destruction from extreme gravitational forces. But neutron stars are not just dense, they are incredibly fast spinning. Some rotate hundreds of times every single second without slowing down. This rapid spinning creates beams of radiation shooting into space. When these beams sweep past Earth, we detect them as pulsars. Pulsars flash like cosmic lighthouses, blinking with perfect precision. Some are so accurate they rival atomic clocks on Earth. But the extremes do not stop at density or speed. Certain neutron stars have magnetic fields beyond human comprehension. These are called magnetars, the most magnetic objects ever discovered. Their magnetic strength is trillions of times stronger than Earth's field. It is powerful enough to distort atoms and tear apart molecules instantly. Even from far away, their influence can disrupt electronics and signals. If one came close, it could wipe out life completely on Earth. Fortunately, magnetars are located safely far from our planet, yet their existence proves space can create unimaginable extremes naturally. Magnetars can also release sudden bursts of high-energy radiation. These bursts can outshine entire galaxies for brief moments in time. Such explosions are among the most powerful events in the universe. Scientists monitor them carefully to understand their unpredictable behavior. But even neutron stars have limits when pushed beyond certain boundaries. When two neutron stars collide, the result is truly spectacular. The collision releases energy equivalent to multiple supernova explosions combined. It also produces gravitational waves rippling through space itself. These waves were first detected, confirming predictions by Einstein's theories. The event also creates heavy elements like gold and platinum. Yes, the jewelry we wear may come from ancient cosmic collisions. This connection makes neutron stars even more fascinating to study. Yet something even more extreme can occur during these violent mergers. The combined mass can collapse, forming an even larger black hole. This shows how different extreme objects are connected in cosmic evolution. But scientists have discovered even stranger neutron star behavior recently. Some appear to glitch, suddenly changing their rotation speed without warning. These glitches reveal hidden details about their mysterious internal structure. Others emit repeating fast radio bursts, puzzling astronomers worldwide. These signals travel billions of light years, reaching Earth instruments. Their origin remained unknown until linked to magnetars recently. This discovery solved one mystery, but opened many new questions. How do such small objects hold such incredible energy within? What happens deep inside where matter exists in unknown states? Scientists cannot recreate these conditions in any laboratory on Earth. So space itself becomes the only place to study such extremes. Neutron stars act like natural experiments, testing the laws of physics. They push matter to limits impossible anywhere else in the universe. Their study helps scientists understand nuclear forces at extreme densities. It also connects quantum physics with gravity in unique ways. This makes them essential for unlocking deeper cosmic secrets. Despite their size, they have enormous influence on surrounding space. Their radiation and gravity shape nearby matter and energy flows. Observing them requires powerful telescopes and precise instruments constantly improving. Each discovery adds new layers to our understanding of extreme space. Yet we have only scratched the surface of their mysteries. Beyond neutron stars, even more terrifying extremes may still exist. Objects that challenge not just physics, but imagination itself. The universe never stops surprising us with its hidden wonders. Every answer leads to deeper and more complex questions, and the journey into cosmic extremes becomes even more intense, because something far more powerful is waiting in the next chapter. Just when neutron stars seem unbeatable, something even more extreme emerges. Imagine explosions so powerful they briefly outshine entire galaxies completely. These events are known as gamma-ray bursts, the universe's brightest flashes. They release more energy in seconds than our sun produces ever. First discovered accidentally, they shocked scientists with their sudden intensity. These bursts appear randomly from distant regions across the universe. For a few seconds, they dominate all other cosmic light sources. Their energy travels across billions of light years, reaching Earth. Despite their distance, they remain detectable with advanced space instruments. There are two main types of gamma-ray bursts observed. Short bursts last less than 2 seconds, yet are incredibly powerful. Long bursts can continue for several minutes with sustained energy release. Each type forms from different extreme cosmic events. Short bursts are linked to neutron star collisions in deep space. Long bursts originate from massive stars collapsing into black holes. Both scenarios create conditions beyond anything humans can replicate. During these events, enormous jets of energy shoot outward rapidly. These jets move close to the speed of light itself. Anything caught directly in their path faces complete annihilation instantly. The radiation is so intense it can strip away planetary atmospheres. If aimed at Earth, it could cause global extinction-level damage. Fortunately, most bursts occur far away from our galaxy. Still, their existence reveals how dangerous the universe can be. Scientists study their patterns to understand their unpredictable nature. Each burst carries valuable information about distant cosmic environments. Observing them helps map the structure of the universe. They also act as signals from the earliest times after formation. Some bursts come from billions of years in the past. This allows scientists to look back into cosmic history. Special satellites constantly scan the sky for these sudden flashes. When detected, telescopes quickly focus to capture afterglow details. The afterglow can last longer across different wavelengths of light. This provides clues about the surrounding space and explosion mechanics. Surprisingly, gamma-ray bursts can form heavy elements during explosions. These elements spread across space, contributing to future star formation. This shows destruction can also lead to creation in the universe. Yet many mysteries still surround these extreme events. Scientists question how such focused jets remain stable over long distances. They also study what determines the direction of these deadly beams. Understanding these factors could help predict future bursts better. However, prediction remains extremely difficult due to their random nature. Advanced technology continues improving our ability to detect them early. International collaboration helps share data across observatories worldwide. Each new observation challenges previous theories and models. Sometimes bursts behave differently than expected, confusing researchers. These surprises drive innovation and deeper investigation into cosmic physics. The energy scales involved are almost impossible to fully comprehend. It pushes scientific understanding to its absolute limits. Even with modern tools, much remains unknown about their origin. But their study connects multiple extreme phenomena together. Black holes, neutron stars, and massive stars all play roles. This creates a complex network of extreme cosmic interactions. It shows the universe is far more dynamic than once believed. Not a silent void, but a place of violent, powerful events. Gamma-ray bursts are among the clearest examples of this truth. They remind us space can be both beautiful and terrifying simultaneously. Their brightness hides incredible destructive potential beneath, yet they are only one part of cosmic extremes. Even more mysterious forces exist, shaping the entire universe quietly. Forces that do not explode, but influence everything around them. Something invisible, yet incredibly powerful, controls cosmic expansion. Scientists call it dark energy, one of the greatest mysteries ever. Its effects are subtle but dominate the fate of the universe. Understanding it may change everything we know about reality, and that mystery takes us deeper into the ultimate extreme unknown. Beyond explosions and dense stars exists a force shaping the entire universe. It does not shine or explode, yet controls cosmic expansion silently. Scientists call this mysterious force dark energy, and it dominates everything. Surprisingly, it makes up most of the universe's total energy content, yet we cannot see or directly detect it with current technology. Its presence is known only through its strange effects on space. Instead of pulling things together, it pushes galaxies farther apart. This discovery completely changed how scientists understand cosmic evolution. Long ago, gravity was expected to slow the universe's expansion, but observations revealed expansion is actually speeding up over time. Something unseen is driving this acceleration against gravitational attraction. That something is dark energy acting on the largest scales possible. It fills all of space evenly without forming structures like matter. Its influence grows stronger as the universe continues expanding outward. This means distant galaxies move away faster as time passes. Eventually, some may move beyond our observable universe forever. This creates a future where the night sky becomes increasingly empty. Galaxies will drift apart, leaving darkness between isolated cosmic islands. It is a slow but unstoppable transformation of the universe. Scientists are still unsure what dark energy truly is. Some believe it is a property of space itself. Others suggest it could be linked to quantum energy fluctuations. Another theory proposes entirely new physics beyond current understanding. Each idea attempts to explain its mysterious, repulsive behavior. Despite many studies, no single explanation has been confirmed yet. Powerful telescopes continue mapping galaxies to measure expansion accurately. These observations help refine models of dark energy's influence. Data from distant supernovae first revealed its shocking existence. Those exploding stars acted as markers, showing unexpected cosmic acceleration. This discovery won major scientific recognition and reshaped cosmology forever. Yet many questions remain unanswered even today. Does dark energy stay constant or change over time? Could it suddenly become stronger or weaker in the future? If it changes, the fate of the universe could shift dramatically. One possibility is a scenario called the Big Freeze. In this future, stars burn out and galaxies drift into darkness. Another possibility is the terrifying Big Rip scenario. Here, expansion becomes so extreme it tears apart galaxies and atoms. Even space itself could be ripped apart at the smallest scales. These outcomes depend on the true nature of dark energy. Understanding it is one of science's greatest challenges today. It connects cosmology, quantum physics, and fundamental forces together. Solving this mystery could unlock a deeper theory of everything. It may reveal hidden dimensions or unknown properties of space. Dark energy shows the universe is not just about visible matter. Most of reality exists beyond what we can directly observe. This idea challenges human perception and scientific assumptions deeply. It forces us to rethink what reality truly means. Even empty space is not truly empty as once believed. Instead, it may hold vast, unseen energy shaping everything. This realization is both fascinating and unsettling at the same time. It means the universe is far more complex than imagined, and we have only begun to uncover its hidden layers. Dark energy operates quietly, yet affects every galaxy and star. Its power surpasses even the most violent cosmic explosions, because it determines the ultimate fate of everything in existence. Still, it remains invisible and deeply mysterious to scientists. Research continues using advanced missions and global collaborations. Each discovery brings us slightly closer to understanding its nature, but complete answers remain frustratingly out of reach. And that is what makes it one of the most extreme forces. Not because of violence, but because of its universal dominance. Yet there is still one final mystery even deeper than this, something that challenges reality at its most fundamental level. And it may be the most extreme concept in all existence. After everything explored, one final mystery remains beyond imagination itself. It is not an object or force, but a question about reality. What if the universe itself is not what we think it is? This idea pushes beyond physics into the deepest philosophical territory. Scientists and thinkers have debated this for many years. The concept is known as the nature of reality itself. Some theories suggest the universe could be a simulation, a construct created by intelligence far beyond our understanding. In such a case, everything we see might not be fundamental. Space-time and matter could be part of a larger system. This idea may sound strange, yet has scientific discussions behind it. Advanced physics sometimes hints reality behaves like coded information. Quantum mechanics reveals particles act unpredictably when observed closely. They exist in multiple states until measured by an observer. This challenges the idea of a fixed objective reality. It suggests observation plays a role in shaping outcomes. Some scientists explore whether consciousness connects to these effects. Though controversial, it remains an open area of investigation. Another idea suggests our universe is just one of many, a multiverse where countless realities exist simultaneously beyond our reach. Each universe could have different laws of physics entirely. Some may allow life, while others remain completely lifeless. This expands the scale of existence beyond comprehension. It means our universe might not be unique at all. These concepts are extremely difficult to test or confirm, yet they arise naturally from advanced theoretical models. String theory and quantum gravity sometimes point toward hidden dimensions beyond the three we experience every day. These extra dimensions could exist folded within space itself. We cannot see them, but they may influence physical behavior. Understanding them could unify all known forces into one framework. This is often called the search for a theory of everything. Achieving it would revolutionize science completely. It would connect gravity, quantum mechanics, and cosmic expansion together. Yet progress remains slow due to the complexity involved. Experiments at extreme energies are difficult to perform on Earth, so scientists rely on cosmic observations to gather indirect evidence. Every extreme phenomenon studied contributes pieces to this puzzle. Black holes, neutron stars, and dark energy all provide clues. They reveal limits where current theories begin to fail. These failures guide scientists toward deeper understanding, but the final answer may still be far beyond reach. It may require new ways of thinking entirely, new mathematics or concepts not yet imagined. This is what makes the universe so endlessly fascinating. No matter how much we learn, mysteries always remain. Each discovery opens doors to even bigger questions, and those questions lead us further into the unknown. The most extreme thing in space may not be physical. It may be the fact that we do not fully understand reality. That uncertainty is both humbling and inspiring at once. It drives curiosity and fuels scientific exploration forward. Humanity continues searching for answers across the vast cosmos, using technology, imagination, and determination combined. One day, we may uncover truths that change everything, or we may discover even deeper mysteries waiting beyond. Either way, the journey will never truly end, because the universe is larger than any single explanation, and its extremes go beyond anything we can currently imagine, from crushing gravity to invisible energy and unknown realities. Everything points to a cosmos filled with endless wonder, a place where extremes define the boundaries of knowledge and challenge us to keep exploring without limits, because the greatest discoveries are still waiting ahead, and the ultimate extreme may be the mystery itself.